Hello, everybody. It's me again, Teddy, with my software development on class. We are going over CC's Candy Corner's inventory management system testing plan. Now, introduction. What is a testing plan? Well, a testing plan is a document that details the scope, objectives, resources, and schedules of all software testing activities. The main purpose of it is to guide the testing process, ensuring that all aspects of the software are thoroughly being examined for any possible defects, as well as verify that the software is meeting all required specifications. The reason why this is important is it helps us ensure that the software is fit for its purpose, it's reliable, it's efficient, it's usable and maintainable. It identifies all potential problems in the process as early as possible, thereby reducing any costs and impacts that you would have to address later. Because as we know, the further in the process you get, the more expensive it gets. We want to get those as quickly as possible. It also provides a clear roadmap for all stakeholders, developers, testers, and customers on how the software is going to run and should behave. It establishes milestones and deliverables. That way we can track how the progress of that software is coming along. And then for compliance, we want to make sure that all critical systems provide evidence that quality standards are being met, as well as safety standards. We do this. We're going to start with our first test here. We're going to do testing of the add data function. The purpose of this is to verify that the new bracelet details can be successfully added to the inventory and that all inputs that are invalid are properly rejected. This is fulfilling the requirement of the functional requirements 001. So first, we're going to start that test. This is the expected outcome. The user would navigate to the Add Bracelet interface, where then they would click on the Add Bracelet button. From there, it would display the Add Bracelet form with the bracelet details. Once the user has input the details in it, we have our first validator. We'll get to many of those. We're going to be talking about input validation and why it's like a must-have for this presentation shortly. But our first one here asks, are there any invalid inputs? Is it a non-numerical price? Is it a negative quantity? If yes, then the user should receive, if there are invalid objects in there, the user should see a displayed error message that says, hey, invalid input in this particular field. And it will say that it's been rejected and it won't proceed from there. The test fails there. However, if the object is valid and is matching the requirements, the business requirements, then it will move on to the next step, in which it will create the bracelet object. It will call up the inventory manager add bracelet. Then it would provide another validator. It says, is this business logic valid? It will now test the system to ensure that the system itself put in a valid ID. We all know that they're unique IDs. Nobody should have anybody else's ID. Or no bracelet should have any other bracelet's ID. We're not talking about people here. So we want to make sure that it is following that. If it does, then we can move on to the next step. If it doesn't, it kicks back a business logic error. And then they have to go back and say, hey, this wasn't input properly. It was kicked out. This test failed because of this reason. We need to try again. If it was successful, we move on to the data layer of the database manager. And then there's another validation there. Was the insertion into the database successful? If no, then it returns you back to the application layer with an error. If it was successful, it successfully inserts it and it updates the in-memory inventory list. From there, it should proceed to another validator where it asks was the operation successful. If no, displays the error message and shows that the outcome has failed. If the operation is successful, display a confirmation message. It will clear the form of the fields in the form. It will verify that you can see that the new bracelet has been added, in fact, to the inventory view. And then it will show you the outcome of the test, which is passed. This is the expected outcome. Now, the expected outcome for testing to remove data. We are doing this for situations in which CC, the owner of the shop, has made bracelets of this particular design. Maybe they're not selling well. Maybe she wants to update it with a new design. What she can do is take down older listings by removing the data, the bracelets themselves. This test is to ensure that bracelets can be successfully removed and that attempts to remove non-existing items kick back with an error. I handled gracefully without system crashes. The reason why I wanted to stress that here is because sometimes a system can just stop working and not do anything, and to me that is the opposite of graceful. So when, if the system does crash out, we want it to be an expedient, like kick it out, doesn't put in any of the data, because the last thing we would want is for a system to input a bunch of data that's not valid and have it ruin the integrity of the database. Now, this functional requirement is 004, which is delete items. First, the user would go to the delete items button. They would select it. Then it's going to prompt the user to select which bracelet they would like to delete. Then we have another validator here where the tester inputs the bracelet ID to verify it is actually within the system. If not, it says, hey, cannot find this, excuse me, I jumped ahead of myself. We got to get to that point. First, if you did put in a valid input, let's say you put in numbers or you put a decimal point or a special character that's not allowed there, it will kick it out with a displayed message saying invalid ID format, and it will fail the test. If it was properly validated, it would move on to the application layer where it calls up the inventory manager to search for the bracelet. If it finds it, it says yes, the bracelet was found. If it's no, it will turn back the bracelet not found message to the presentation layer. Once it is successful, we validate was the operation itself of removing the item successful. Did it fully remove it? Did it delete the item from not just the table, but maybe there was a local file that was stored with it to represent that item? That file needs to be removed as well. Did it completely remove those? No. Well, then we're going to display the error message, bracelet with ID not found. If it's not found, and the outcome's going to fail. If the operation of finding it was successful, then it would display the bracelet's details so the user can see it, and then it will ask the user to validate their confirmation deletion. This is a highly important thing. Every step of the way, I'm going to keep saying this throughout this presentation, we always want to validate, especially with deletion. You want to add something, that's great. Validate it. We need to make sure it's properly going into the system and it's not going to mess up. Do you want to remove something? Great. We need to validate that it is actually the item you want to delete. It would be a pain in the butt if you deleted the wrong bracelet and had to go back in and recreate that item and, run the risk of getting a different unique ID, which could, impact, how it's displayed on a website, as an example. Maybe not calling up the right item, etc. We want to make sure it's following all of those logical rules. So if the user does pull it up properly, they can confirm the deletion. From there, the inventory manager runs the delete bracelet function, and it validates was it successful. If yes, it continues forward. If not, it returns the deletion failed to the presentation layer. Now, if the operation's successful, like I said, continuing that moving forward. If the deletion was not successful up here in this aspect of it, it will continue down here under this path of no, and you should get an error deleting message. Any no up here should kick back down and eventually give you this message, error deleting bracelet. It may show you why it is that there was an error deleting the bracelet. But overall, we will always want to make sure that if there is an error deleting the bracelet, no matter what, we're going to let the user know. It's going to fail the test, but if it's successful, it should update the inventory list, give you a display confirmation, because like I said, always want to confirm, always want to be transparent about what is going on. Then we're going to verify that the bracelet's no longer in the inventory, and if it's no longer there, then the outcome of the test has passed, and that is the test for removing data. Now to update data, or the U in the crude section of it, the objective of this test is to verify that existing bracelet stock quantities are valid and that out-of-stock items can in fact accurately be adjusted. I said out of stock, but I also want to add emphasis. If there is an item that is in stock, you want to be able to mark it as out of stock. If you run out of stock, if the system's not properly, or maybe it over or under counted how many bracelets you may have in inventory. Maybe it's a user error and you counted 5, but there were only 4. Those things can very much mess up with the system. So we want to make sure that we're able to have the user adjust for any user errors. And the test for this, we're going to want to verify that existing bracelets and quantities can be updated to either the proper amount, cannot be negative numbers. I'll get to that shortly. We want to make sure whether or not they're properly displaying as in stock or out of stock, and that any updated, any attempts to update any bracelets are going to be able to be successful without any system crashes. This is the fulfilling the functional requirement FR003. So starting out, the user would be on the home page. They would click the update stock section. It should prompt a user to input a bracelet ID that they may want to update. Then the tester inputs that bracelet ID. It checks to see if the format is valid. If no, it displays the message invalid ID format, and the test fails. If yes, it goes to the call inventory manager get bracelet by ID search. Then it determines whether or not it's been found. If no, it says not found. And then we continue forward down the display path of test failed. If yes, it will say bracelet found, go to the operation successful, then it will display the current bracelet details, input, then it will ask the user to input the new quantity or the status, then it will ask them for any business logic. So is it a negative number? Did they update a quantity? Or did they try to change the status to something that's not proper? Like, let's say they wanted to say sold out instead of out of stock. Well, it's not going to understand sold out. So it would kick back with a, this can't be negative or invalid input. But if it is valid, it will move on to the call inventory manager update bracelet function, and then validate whether or not it was successful there. If it's not, it says update failed. If it is, update successful, we can keep moving forward. As I mentioned, when it says update failed here, if not, then it should kick back out an error message saying error updating stock, please try again. Then it should move the user back to the beginning of the update stock section, with back to the form itself, rather, so they can input that information and try again. But if they're successful, it should update the inventory. It should display a confirmation saying that the stock has been updated successfully. Verify that the user can in fact see the data properly in inventory view, and then move the test to the outcome of passed. Now for the custom action, this is, since it's an inventory management system, I figured it was imperative and it was a must-have for my associate, aka my wife, to have reports to let her know when stock is getting low. That way she can stay ahead on making the bracelets, because they do take time to make. Now, the objective of this test, like I said, that it verifies that the system can accurately generate a report of items that fall below a certain threshold. I haven't really talked about what that threshold is yet with the owner. But typically, I think we're going to start out with is anything that falls below 5 bracelets in stock should generate, when the user goes to generate the reports, it's going to populate any bracelets that fall below 5 bracelets. That's the example I'm using here. That basically... excuse me, I lost my train of thought. I got distracted by what I was saying in the presentation. But basically, it also will, if there are errors in this, we also want to make sure that they're gracefully, handling and being executed without crashing out. We don't want system crashes. We want stable uptime, especially during times of peak. So we want to make sure that we're verifying every step of the way that the data is being properly handled and that the system isn't just going to, like I did earlier. So yes, the test for this, we start out, the user navigates to the report section. From there, the user clicks on the low stock reports button. It should display then a report. This is where it prompts for that threshold. The tester inputs, or it validates whether or not any bracelets fall under that threshold. It asks, are there any that have numerical or issues? Is it a negative number? If not, then there shouldn't be. It kicks back the display error message, invalid threshold value. Test fails, but if it's successful, it calls up the inventory manager get low stock bracelets threshold, which is 5. And it says, are low stock items found? If no, and everything's in stock, everything's proper, nothing falls below that threshold, it will say no low stock items found. If there are, it will say low stock items found. Then we move to the next step. It says, is this operation successful? If no, it'll say no items currently below the specified stock threshold. So that way, we want to be able to test. Maybe I know I mentioned for the example I'm using 5, but maybe the user wants to test it for 3 or 4 or 6 or 7. Maybe they want to test different thresholds to see. Maybe they're under 5. They're not, or they're under 5, but they're not under 4. Or they're under 7, but they're not under 5. You want to see where exactly those things are within the report. So we want to make sure if there are none whatsoever, it displays that. If we have some of them, we want to make sure that it's displaying how many of them are properly done there. So if no, it's not going to generate that report, and the test is going to pass. Because in this test, outside of the one outcome up here where it's an input or an invalid input where the test failed, the tests both have positive resolutions down here. So if there is no low stock, it will positively display this message, hey, good job, no items currently below the low stock threshold, and it passes that test. If it generates a low stock report, it displays that user report, verifies that the user then verifies accuracy of that report, and the outcome is test passed. Now, I had mentioned before why input validation is a must-have, even though it is a non-functional requirement. Basically, this non-functional requirement is a must-have because it ensures data integrity and it prevents programs crashing from bad data. As I mentioned that before, if you put negative numbers into areas where there shouldn't be negative numbers, it could crash out. If the system is inputting Let's say it's going through the process of creating a bracelet and it crashes out halfway through or something of that nature. Um, we don't want it putting in incomplete, incorrect data into the system. So that type of bad data could cause it to crash out. And the reason we do this at every functional test level is there are many, many points and times in which a program could fail, and it could fail in ways you don't even think. So by putting in validators as often as possible, we're being as specific as we can, to try to, overcome some of those things that may lead to bad data, such as, maybe a system having a hiccup or hallucination. The way we can do that is by following these key validation principles and mechanisms. We can implement format and type checks. These basically verify that inputs are matching the data types we had already specified. For an example, if you try to go into quantity and change it from in stock or out of stock to sold out, it's not going to match that data type because it's only two data types: in stock, out of stock. Another example for that is trying to put your name into quantity, or let's say you're doing quantity and you accidentally put in the numerical amount in there, so you put $15.99 as bracelet price in the quantity instead of the thing. We're always wanting to make sure that those kind of things get rejected because we need specific information in specific fields. We can do this also by providing range checks that confirms all numerical entries fall within the logical bounds. As I mentioned before, non-negative numbers for currency, non-negative numbers for inventory, stuff of that nature. It also checks and ensures that all unique IDs are in fact unique. We can also do existence checks. I had mentioned this before, and going down the flow of checking out whether or not an item actually exists within the system. Let's say you're trying to delete a bracelet that does not exist. We want to make sure that it's validating and kicking that out to let you know, hey, that's not showing us properly in our system. If it should be, that can let us know that there's issues that need to be resolved, and why is this one bracelet missing? Other bracelets could be missing as well, so we'd want to, investigate the existence to make sure that they're actually there. Because things can happen where, they try to delete it and it doesn't properly delete it. As I mentioned before, any local files that may come with it. We also want to make sure when a bracelet's removed, anything locally that stores that kind of data would also be removed with it. We can also do business logical enforcement and controlled vocabulary. Controlled vocabulary restricts inputs to predefined valid options, like I said, in stock, out of stock. Business logic enforcement applies specific business rules beyond the basic data types. So, point example I used here as an example would be preventing the negative stock levels, ensuring that each ID is in fact unique, because that can cause false positives within the system, delete bracelets that shouldn't be deleted, etc., etc. But also, it's a must-have. One of the reasons to buy is because we always want to provide clear user feedback. This provides users with an immediate and understandable error or confirmation message for all input and processes outcomes. This way, it provides documentation at every step of the level. So let's say the user or the owner cannot properly run a function. Well, then I can go in and see what exactly the error code was generated, so I can assist them and better teach them and empower them how to better use that software. Maybe it's a user error input. Like I said, maybe they put the price into the quantity. Maybe they tried to put sold out instead of out of stock, stuff of that nature. Providing feedback at every step of the level also educates the user and gets them better at the use of the software, so you have less and less that you have to do. But yeah, this is a major it's a must-have, but to me, it's, although it's non-functional, it's not required for the program to run, it is an absolute must-have for me. Thank you guys so much. I hope you guys have a great evening. Bye.